Hi everybody and welcome to the third video on solving linear inequalities. If you are unfamiliar with inequalities, please watch the previous two videos. If you are happy with those, then I'm glad that you started. In this one here, we will be looking at representing inequalities on a number line, the solution. I would highly recommend that you stop the video now and give it a try, and we can do it together. Okay. So let us start. So the first one is x plus 5 is greater than 3. So we'd like to get x alone. So what we're going to have to do is remove the 5. So when we do that, we take it over to the other side and the sign changes. So we get that x is greater than 3 minus 5, which is negative 2. So that's the solution. What we're also going to cover is how to represent this on a number line. So we're going to assume that all of the numbers are real numbers, so they're not integers or anything. So I'm just going to put up a few numbers here. So minus 2, minus 1, 0, 1, 2. Okay, so the first thing that you need to remember is what dots represent. So this here, these two are what we call strict inequalities. So that's strictly greater than and strictly less than. These correspond with open dots, okay? So the open dots mean that they do not include that number. We also get the ones that are less than or equal to and greater than equal, and those two correspond with closed dots. Okay, so please remember this notation. Okay, so this one here is greater than negative 2. So we're going to look at negative 2. It's a strict inequality, so we're going to have an open dot at negative 2. And it is greater than it, so we're going to go to the right-hand side. And we just draw an arrow because there's no, well, we just have that it's greater than. Let's have a look at another example. So we have 2x plus 1 is less than or equal to minus 1. So first let's get the 2x by itself. So we take over that plus 1 and it becomes a negative 1 when we take it over, the sign changes. So we have 2x is less than or equal to minus 2. So then we would like to get the x by itself. So we divide both sides by 2. And then we get x is less than or equal to negative 1. So again, I'm just going to draw a little number line for us. Okay, so which dot should we use to represent our line at minus 1? An open or closed dot? Well, because it's inclusive, it's included, it needs a round dot. So at 1, we have a round dot. And this time we have that x is less than. So we're going to go to the left-hand side. Okay, let us do a few more. So then we have 4x minus 5 is greater than 19. So we're going to take that 5 over. So we have 4x is greater than 19 plus 5. So we have 4x is greater than 24. And then we would like to get the x by itself. So we divide both sides by 4 and we get that x is greater than 6. So again, we're going to have a number line. You don't have to put in a lot of numbers. I'm just going to have 5, 6, 7. And we're going to have 6 being the pivotal one. So 6, and it's a strict inequality. So it's an open dot at 6. And x is greater than that. So we go to the right-hand side. So greater than, we go to the right-hand side. Less than, we go to the left-hand side. Okay, we have minus x plus 3 is greater or equal to negative 6. So first of all, let's get the x by itself. So we're going to take the negative 3, the 3 over, it's going to become negative 3. So we got negative x is greater than or equal to negative 9. We would like to get the x by itself, so we're going to divide both sides by negative 1. And then what we get is x. And please remember from the previous lecture, when we divide by a negative in an inequality, the direction changes. Negative 9 divided by negative 1 is positive 9. And this on a number line, so we have 8, 9, 10. which kind of dot should we use? Well, it's less than or equal to. So when it has an equal to, it's a closed dot. And it is less than 9. So we're going to go to the left-hand side. Last example. So we have x plus 2 is greater than 3 plus 2x. Let's get our x's over to one side. So I'm going to take this 2x over, and it's going to become a negative 2x. And then the 3 will stay, and this 2 we're going to take over, and it will become a negative 2. So we have negative x is greater than 1. I'm going to divide both sides by negative 1 to get x by itself, and then I get x. And if you remembered this, well done. To swap the sign when dividing by negative, and we get x is less than 1. So again, I'm just going to have a few numbers here. Okay, so our point is 1. It's a strict inequality, so it is an open dot, and it is less than, so we're going to go to the left. Okay, I hope that you've understood how to represent it on a number line. An important bit is to remember that your strict inequalities correspond with open dots, and the ones that are less than and equal to correspond with closed dots. Please follow the next video to see how it is done with set builder notation, and the video after that we will do when there's things on either side of the X.